Welcome everyone to our YouTube series, Test Prep Made Easy. So in this particular series, we are going to post regularly questions on our YouTube channel. The questions may pertain to CAT preparation, maybe pertaining to GMAT preparation, as well as of various topics which are tested in these particular exams. For example, quants, LRDI, English, and various areas which are tested. And each day we will handle certain number of questions and their video solutions. The best approach is to these questions in these videos. So have a happy preparation ahead and enjoy the video. Thank you. These are the 4 questions that we are going to try today, guys. Um, Starting in few seconds, we will be having the solutions one after the other. So if you want to try the questions yourself, we recommend you to pause the video at this point and try the questions once yourself before looking into the solutions of these questions. And if you just want to enjoy the video, then just go ahead and check the solutions now.
This is a special series question, and we have touched upon a series similar to this in our lessons as well. It's just a variation on that. So I'm just going to first convert it to that form, and then going forward, you should be able to identify. Um, First of all, if you look at each of the denominators here, if you notice each denominator is of the form a square minus b square. Or to be a little more precise, it is of the form a square minus 2 square, right? Every time you're subtracting 2 square. So if you use the a square minus b square factorization, so that will be effectively a plus b, which is 2, into a minus b, right? So each denominator is of this form. So let us first utilize this and rewrite the entire expression in that way. So the first term will be 1 divided by 3 plus 2 into 3 minus 2, which is 5 into 1. I'm writing it as 1 into 5. Same thing. Then again, 1 by 7 plus 2 into 7 minus 2, which is 9 into 5. Again, I'm just reversing the order. Second, the third term, you can do it yourself. It will be 11 minus 2, 9, and 11 plus 2, which is 13. So this thing will go on, right? And it goes on till 1 divided by 39 minus 2, which is 37, into 41. So this is what the expression is, right? If you have done our classes, you will definitely know what to do next. So just get this difference or difference of these terms here, these numbers here, basically. Uh, that is 5 and 1, 5 and 9, 9 and 13. So these differences. So the difference is 4. So try to get 4 in all the numerators. So all I have to do is multiply the entire thing by 1 by 4. So if I do that, I get a 4 in each of the numerators, right? So let me just split this as 5 minus 1. Let's split this as 9 minus 5. I'm just writing the 4 in different ways, uh, noticing whatever we have in the denominator. So this is going on, and this will carry on till 41 minus 37 upon 37 into 41, right? Now, all you do is just break these fractions, or rather break this into partial fractions. So what you have is 5 divided by 1 by 5 is 1, minus 1 divided by 1 by 5. So that is this. 1 divided by 5, sorry. So this is 9 divided by 5 into 9. So the 9 will cancel off. So I'm just splitting this into two parts. That's all. 9 divided by this minus 5 divided by this. That's all. So 9 divided by this is 1 by 5. And 5 divided by this is 1 by 9. At this moment, you should be able to see that this cancellations are happening. So the 1 by 5 cancels off here. Similarly, if you carry forward with the next term, you'll have something like 1 by 9 minus 1 by 13. So again, there will be cancellation, and you can see this 1 by 9 goes off. So these cancellations will carry on, right? So the last term, by the way, I mean, let me put a dot 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 here. And the last term will have 1 by 37 minus 1 by 41. And just notice the symmetry in these kind of cases, that is always faster. Notice that after the cancellations are happening, this first part of the first term is remaining, right? So symmetrically speaking, the second part of the last term should be remaining. Everything else should cancel out, right? For instance, this 1 by 13 will have a term next to it, which will cancel it. And 1 by 37 will cancel out with the previous term, some with something, right? So this cancellation is bound to happen. So once that happens, you're left with obviously this 1 by 4. Do not miss out this 1 by 4 multiplied to 1 minus 1 by 41. These are the only two things remaining, and which is essentially 1 by 4 into 40 by 41 cancels out and reduces to 10 by 41. So that should be the answer out here, option 4 here. This is the general process of solving this particular question. I would like to explain one shortcut as well in terms of the calculation bit. But do apply that shortcut once you have understood this idea. Don't mug it up. Um, Here onwards, if you check, I mean, after this first term, after this one that was remaining, all the terms are actually reducing, right? 1 by 5, 1 by 9. These are even smaller than 1, right? I mean, this is 1 by 13. The last term that you see, 1 by 41, that is even lower than I mean, much lower than 1, right? So approximately speaking, whatever we are going to get. So in this case, for example, I don't have to see what is the exact value. I know that this thing will be fractionally very low compared to 1. So when I'm subtracting it from 1, this value is almost 1, a little less than 1, but almost 1, right? And once I multiply this 1/4, the result will be very, very close to 1/4, right? So 1/4 into 1 minus something insignificant, something like that. So just don't consider this. So 1/4 into 1 is basically 1/4, right? So it is very, very close to 1/4. So if you look at the options, because in these kind of questions, you'll always have options. You cannot input a fraction as the answer. So if you look at each of the options out here, 5 by 41 is close to 1 by 8. That is not close to 1 by 4. 18 by 37 is close to half. 31 by 41 is close to 3 by 4. Only 10 by 41 is close to 1/4. So typically in these kind of cases, you'll always have the options not very close to each other. So you can use the options. If you do have options close to each other, then you can solve it completely. But always do check it once. So the reason I'm telling you this, so if you do understand this idea, let me show you how fast you can actually solve this. This is a different way of representing the same thing. So that first step has to be done. So once you have done that first step, so you have reached this point and so on, whatever. So see, I'm not looking at the last one. So I know that these differences are 4 each, right? So I know there is a 1/4 that is going to come out. And after that, only this 1 by 1 will remain, right? So this is going to remain as 1. So whatever is the last part, so I know that this is roughly close to 1/4. So see, I didn't calculate anything at all. I just need to just visualize this. Whatever is the difference here, and then obviously I have to check this term. So whatever is in the new denominator. Let me give you another example to explain this further. So suppose I have something like 1 by 3 into 7 plus 1 by 7 into 11. Did I take 4 again? Let me take something else. 1 by 3 into 8, let's say. 1 by 8 into 13. 1 by 13 into 18. And this goes on till a certain number of terms. So I know the difference is 5 in this case. So I need a 1 by 5. And then this 1 by 3 will remain, right? So the first term, the 3 will remain. So 1 by 5 into 1 by 3 is 1 by 15. So this entire thing will be approximately equal to this 1 by 15. By the way, let me just write this properly. Yeah, my your marker is behaving a little abruptly today. So this will be the approximate solution or answer value of this particular summation. An interesting point to note here, if this is actually added to infinite terms, now since the values are reducing and getting closer and closer to 0, we can figure out the sum of infinite terms in these cases. So if you reach that point, I mean, if it goes till infinity, then the value will not be approximately 1 by 15. It will be exactly 1 by 15 because everything else will cancel out. It goes on till infinity, right? So there will be complete cancellations. So all you have is, in that case, the answer will be exactly 1 by 15. But any which way, I don't think that is going to come in CAD. These cases also, you can utilize the option and use this idea. But that's all I had to mention for this particular question. The answer was option 4. And that's it for this question. Hopefully everything was understood. Thank you. All right, we have an interesting question here. Now, on the face of it, if you read a question like this, anything related to the nature of roots, so the information tells us that this polynomial has exactly two real roots. So if it's talking about real roots and stuff, then if it's a quadratic, then typically we will be looking at the discriminant and trying to figure it out, right? Now, I want to introduce a little bit terminology as well in this solution. So if you look at this expression that is given, this polynomial out here, this specific polynomial has a name to it. It is known as a biquadratic. I'll discuss a little bit on this. Okay, but if I have to explain that to you, I also need to introduce another terminology. Just bear with me a little bit, which is known as quartic. Now, these two are slightly different to each other. Both are polynomials where the degree is 4. So the highest power of x will be 4, both for both of these polynomials. The only difference being in quartic, you will have some terms will or may have at least one of these terms, which is either x cube or x. So effectively, I mean, it's a simple polynomial of degree 4 basically. So the highest power is x to the power 4, but there will be at least one of these two terms, either x cube or x in it. But a biquadratic does not have that. So you can always treat a biquadratic as quadratic on quadratic. For example, if you look at this expression, you can treat x square to be some k or something. Now, this entire expression translates to something like k square plus a plus b into k plus ab equal to 0, right? So this is what it translates to. Because x to the power 4 will be k square and x square will be k. Now, in CAT and all these exams, you will not have over complicated questions whenever you have it on biquadratic. Now, the reason I'm telling you this is because whenever you have a question on biquadratic, you observe that, okay, this type of polynomial is given. Now that you know that, uh, the first thing you should always do is try to factorize it. Don't try to use any Sridhar Acharya or something. Try to middle term factorize it, as simple as that. So if you do it in this case, you will get something like k plus a into k plus b equal to 0, right? With a bit of practice, you don't have to do the substitution of x square equal to k. You can directly do it on x square. But once you have reached this point, just resubstitute. So resubstitute this k as x square. So what you have is something like this: x square plus a into x square plus b is equal to 0. Now coming to our question. So the question is telling us that this biquadratic or this polynomial that is given has two real roots. Now, this is the most important part of this question. It says that there are two real roots. Now, if you look at each of the factors, so one factor is x square plus a, another is x square plus b, right? So let me quickly take this part off. Now, since the question tells us that there should be two real roots, just check this out. I mean, if x square plus a is equal to 0, then x square is equal to minus a. And if x square plus b is equal to 0, then x square is equal to minus b, right? Now, don't consider that minus a is negative. You don't know the sign of a. Now, minus a, this term here, so this minus a, this number, whatever it is, this could be either positive or negative, right? It could be 0 also, but it should be either positive or negative, something like that. We will come to the 0 case after a while. But in this situation, just check this out. I mean, if x square is equal to minus a and a is positive, so if a is positive, then x square is something negative, right? And this has no real root, because if x square is negative, we cannot have any real root. So that is the one situation. Similarly, if a is negative, now x square is greater than 0. Now understand, x square is not greater than equal to 0. It is greater than 0, right? So if it is greater than 0, whatever be the value, so suppose a is minus 5 or something, then this becomes x square is equal to 5. So if x square is 5, then you have plus root 5 and minus root 5 as the two roots. So in any of the cases, you'll have always two real roots, right? So same analysis you can do for b as well. So x square being equal to minus b. So if b is positive, then you will have no real roots. And if b is less than 0, then x square will be positive, in which case you will have two real roots. It's the same thing, exact same thing, just symmetrical over a and b. Now, what is the question telling us? So question is telling us this entire expression should have two real roots, right? Now, what are the possible cases then of A and B simultaneously, if you think? See, if I pick this case and this case, then we don't have any real root at all, right? If I pick up this one and this one, then we get two real roots here, but no real root here. So in total, we'll have two real roots, right? So we can have A negative and B positive. So this is fine. Similarly, if I pick this case and this case, then again, sum total will have two real roots, nothing from here, but two real roots from here, right? So we'll have something like A positive and B negative. So this is also allowed, right? So remember the original cases. So A positive, B negative, that is also allowed. Again, if I pick up this one and this one, then we'll have four real roots, which is again not allowed. So we can have only two real roots, right? So that is also not allowed. So we can have these two possibilities. Now check this out. I mean, whichever you pick up, either this case or this case, A and B are always of different sign, right? So if A is negative, then B is positive. And if A is positive, then B is negative, something like that. So these are happening in conjunction. So if A and B are of different sign, then A into B should always be negative, right? So that should be the answer to this question. Now, coming to that point, I mentioned earlier, what if one of A or B is zero? So let me just explain this on the left side here. Let me take this part off. So if I consider let's say a equal to 0 or something. So just continue from here. So we have x square equal to 0. And in that case, we have just one real root, which is x equal to 0, right? Now, check this out. When a is 0, whether you take b positive or b negative, you'll never have two real roots. You'll either have one real root or three real roots. So that is a is 0. Don't forget that. Just don't consider this situation at all. So you have one real root here. You can either have no real roots, so total of one real root, or you can have two real roots, a total of three real roots. So neither of these two are allowed, right? Similarly, if I consider for b equal to 0, either of these two cases, we are going to have either one real root or three real roots in totality. Also, if you think that, okay, what happens if I get one real root from each of these, something like that. So that can only happen is a is 0 and b is also 0. So if b is also 0, then x square is equal to 0. That you get another real root, but the point is, I mean, sorry, I misworded it. I mean, that is precisely the point I wanted to place. Although we are getting one real root from each of the factors, but that real root is not different. In both the cases, we are getting x equal to 0 only. So in totality, we are getting one real root, which is x equal to 0. Whenever the question is looking for real roots, it's talking about the value of x, right? So that is the end thing that we are going to test out. Not for x square, not for a, not for b. So typically we are looking for x, right? So in this case, in both the cases, so if I have both a equal to 0 and b equal to 0, then effectively what we have is this entire thing goes off and you have x equal to 0. This entire thing is disappearing. You can imagine this from the original equation itself. So you're getting x equal to 0, right? So a equal to 0 and b equal to 0 simultaneously can never happen. I wanted to discuss this last part of analysis a little bit extra because in this particular question that was not mentioned. But what I believe is that in CAT, they're not going to expect you that much of analysis. So in the question, they will mention that A and B are not equal to 0. So you don't have to think about that anymore. And the rest of it, you can solve very quickly if you understand that idea of biquadratic, as I said. I mean, even if you don't understand it, you might have observed it, you might have got the answer in the same way as I explained here. But you can remember this. I mean, whenever you have a biquadratic related question in CAT, typically you will be looking for factorizing it itself. So just try to factorize it straightforward. If it makes it comfortable, just substitute it with something. So x square is equal to something, and then you'll have a quadratic. That is the essence of biquadratic. So once you get that, just factorize it, find the roots, and then figure it out. So yeah, that's all I had to discuss regarding this particular question. A little bit lengthy, but I wanted to add few points to it, to the solution as well. Hopefully everything was understood. Thank you for joining in. This is a very, very straightforward question. There is nothing too much to this. It just says that the roots of the quadratic this are the intercepts of a line, then the line can be which of the following. Now, the simplicity of this question is that you can directly find the roots, right? So the roots are x equal to 1 and 2. So those are the roots of the quadratic. Now it says that this 1 and 2, so we are not focused on x anymore. So 1 and 2 are basically intercepts of the line. Now, what does intercept mean? I hope everybody is aware of these terminologies. You should not miss out a question like this just because you're not aware of the terminology. So whenever you have a line, wherever it's cutting the x-axis and y-axis are the respective intercepts. So suppose you have the x-intercept as a comma 0 and the y-intercept as 0 comma b. By the way, this could be negative also. You can have a line like this where this is positive, this is negative. You can have a line like this is positive, both are negatives. So any which way, doesn't matter. So if the intercepts are this, so you can directly form the equation of the line as something like this. So x by a plus y by b is equal to 1 is known as a two intercept form. I've explained this in details in our coordinate geometry classes, but this is basically the way to figure out the equation of a line if you have the intercepts given. Now, in this particular question, it tells us that these should be the intercepts, right? What it doesn't say is which one is the x-intercept and which one is the y-intercept, right? So either one is the x-intercept and two is the y-intercept, or vice versa. Another way that you can find intercept, so I'm going to show you two methods, whichever is feasible for you, you can try it out. But I'm going to discuss the basics of each of them first before I go into the solution. So this is one method I'm going to use. The other method is, so suppose I have the equation of the line with me, whatever be the line. So something is already mentioned. From here, if I have to find the intercepts, all I have to do is once I substitute x equal to 0, I'll get the y-intercept. And if I substitute y is equal to 0, I'll get the x-intercept. So if you have the equation and you need to find the intercept, then you can do it in this way. And if you have the intercept, you need to find the equation, you do it in this way. So I hope that was clear. So from the intercept to the equation, you use this technique. And from the equation, you need to get the intercepts. You use this technique. By the way, this will be intercepts only. So yeah, it's either way, whichever is comfortable for you. So if you want to use this technique for this particular question, so just take two cases. One case being, so let me take this part off. One case being, one being the x-intercept and two being the y-intercept, and another case being two being the x-intercept and one being the y-intercept. And just figure out the equation, just normalize this. So this case, you're getting 2x plus y equal to 2. This one, you're getting x plus y, x plus 2y equal to 2. And just check whichever is there in the option. So you can see that this is there in the option 2x plus y equal to 2. That comes from this one. So that is one way. The other way is, I mean, just check the options because it's looking for the line, equation of the line. You can never input as an answer. So you have to, you will always be given options in this question. So you have the line, all the equations of the line present. Just substitute any one of them. So if you put x equal to 0, y is coming out to be half. Half is neither of these two numbers, right? So just ignore it. Similarly, here, if I put y equal to 0, I'm getting x equal to half. So that is also not possible. This is silly because if I put x equal to 0, y is 0, y is 0 as x is 0. So that is passing through the origin basically. So this is giving us the intercepts as 0, 0. So that is also incorrect. So this has to be the answer, right? So you can use either of the methods. Both are equally, I mean, good to do. I don't think there will be too much of time difference if you can analyze, put the values quickly and check it smartly. Um, Even the second method should take as much time as the first method. So it's comfortability up to you, whichever you prefer to do. But yeah, that's all I had to mention in this question. Hopefully everything was understood. Thank you. All right, I'm going to discuss two methods for solving this question. I'll start with method one, which is actual method of solving. But then I'm going to discuss a second method where if you play a little smartly, then you don't have to do all of this. So first, let's start with method one. The solution technique, again, the way you are approaching that also matters. So let me show it from objective thinking. So whatever is required accordingly, I'm going to think. So one is this information is given a to the power p is equal to 3 to the power 64. Now the question itself says the only value of a. So effectively, it says that there is only one value of a, and whenever it says that, it means there is only one real value of a. So find the only value of a which satisfies this given equation. Now our focal point is a, right? So all we have to do is try to represent everything in terms of a. So this is the bugging part. So I need to substitute a p in terms of a somehow, right? So what to do? But before getting into that, let us also notice something, that if you look at the left hand side, it's sort of a quadratic on log of a base 3, right? It's a quadratic on this. So let's do something. Let's first start by taking this as x. Now, using the basic idea of logarithms and the relationship with indices, so this is nothing but a is equal to 3 to the power x, right? So 3 raised to x will be the same. So effectively, what you have is this. Now, additionally, that if part, if you look at, we have been mentioned that a to the power p is this, right? So if I can somehow get this p in terms of this x, because x is already this. So if I can get the p in terms of x, that simplifies the whole thing. I'll get a polynomial in terms of x itself, which will be easier to solve for me. So let us try to do that. So I'm trying to get the a to the power p in terms of x. So all I have to do is raise both the sides by p. Sorry. So what you have is something like this, because I hope everybody is aware of these kind of things. Basic indices, the powers get multiplied. So what this is what we have, right? And that is equal to 3 to the power 64. Sorry. So that is equal to 3 to the power 64. So effectively what this means, this part, if you'll notice, by the way, hope you understood, these two are equal. And since these two are equal, so effectively these are equal. So the powers have to be equal, right? So what we get is px is equal to 64, or p is equal to 64 upon x. So now our job is done. So once I've obtained this, now I can get this entire expression in terms of x, right? Because I can substitute the p with x as well as the log a base 3 with x. So let's do that. So the left hand side will be x square minus 12x plus 48. And the right hand side will be 64 upon x. Now the only challenging part out here is this becomes a cubic equation, because if you multiply x on both the sides, obviously x cannot be 0. You get something like x cube minus 12x square. There's something wrong with the marker today. Sorry for that. So plus 48x and then minus 64, I'm getting it on this side, is equal to 0. This is what we have, right? Now, if you remember, the question already told us that there is only one value of a. So the first thing that should strike you is whether this is a whole cube. I mean, not the entire thing, sorry. The left hand side, can this be written as a whole cube? So if you have a minus b cube, the reason I'm considering minus sign is because there are some minus signs in this expanded form. So if you consider a minus b whole cube, the first term is a cube and the last term is minus b cube, right? So if you notice this, this 64, that is 4 cube, isn't it? So let us try to justify whether this is this a minus b, that is x minus 4 whole cube or not. So what are the in between terms? So we'll have a minus 3a square b. Let me just put some spacing here. So we'll have a minus 3a square b, a plus 3ab square, and then a minus b cube. So this is already justified. This is already justified. So I'm taking a as x and b as 4, right? So if a is x, then this is x square and this is 4. So 4 into 3 is 12. So this is also 12. This matches. Out here, this is x, a is x, and this is 4 square. 4 square is 16, and 16 multiplied to 3 is 48. So that also matches. So basically, this is x minus 4 whole cube, right? So once you figure this out, the rest is easy. X comes out to be 4, and this is x. So again, use that idea. Or what you can do is, once you have already done this, you can utilize this. So a is equal to 3 to the power 4, which is 81. So that should be the answer here. Now I'm going to erase this part and then I'm going to discuss the second method. But before going into that, I hope you understood this. The way I have solved this or tried to approach it is objectively thinking what is my requirement. I'm trying to make those substitutions comfortable to whatever I need to find rather than making random substitutions. So you need to take care of that part just to simplify your solution. Whatever is required, try to hit on that rather than just substituting anything with anything else. Okay, so let me take this off and then I'll discuss other methods. Right. So now going into the second method. Now this is a little smarter. Again, similar kind of reasoning has to be done. But what I'm going to do is I'm going to use options in this case. But how to do that? Some of the options I don't have to test at all. Just bear with me. So again, the question is telling me the only value of a. So there will be one value of a which will satisfy this entire thing. And now the most important expression will become this thing: a to the power p is equal to 3 to the power 64. Now, please understand the right-hand side out here. This is something you should be able to observe straight away. It's a pure power of 3, right? So what my argument is, let us try to take a value of a for which the p is an integer value. So let's test those values first, for which p is integer. Because if that doesn't work, then maybe the other ones. Then I have to solve any which way. So this is like you test it beforehand, and it's not very tough to do. So you can do this very quickly. So let's try this out. Just check one thing. A is equal to 72 is very silly. Remember, we are solving for A. Don't forget that. Whenever you're testing options, never forget what are you solving for. So if you take A is equal to 72, now this is not even possible, right? Because 72 has a prime factor 2. So 72 to the power P is equal to 3 to the power 64. This will be possible, but not for an integral value of P. There will be some irrational value of P. So forget about a equal to 72 because that is not a pure, you'll never have a pure power of 3 on the left hand side. So forget about this straight away. This is the silliest of the three options. 27 is a power of 3, but there is a small problem with that. So check this out. 27, if you represent 27 as power of 3, that itself is 3 cube, right? So if you put a as 27, so what you have is 3 cube raised to p is equal to 3 to the power 64. In this case, although you are getting p as a rational number, but you're not getting an integral number, right? So I'm focusing more on integers. The reason being, if it's an only solution, this side, if a is if a is a power of 3, something like that, then this part will give us each of the terms will be integer. So the right hand, the p has to be also integer, right? So that is something you have to understand, because if a is a power of 3, which should be ideally, otherwise there will be irrational numbers. As I said, in that case you will have no options but to solve. So in this case, the left hand side, so log a base 3, that will be an integral number. So whole square will be an integral, multiplied to 12 will be an integral, then 48 added will also be an integral. So left hand side will become an integer number. So the right hand side has to be integer, right? So that was my argument. So that is why I'll not even test 27. What I will find is, so let me share that as well. I can see that 27 is a power of 3, but the problem is 27 is 3 cube, and the 64 is not a multiple of 3, right? So 3 cube raised to something, if it gives us 64, then this something cannot be an integer, right? That is my point. Anyhow, but you can elaborately test that out as well. So that leaves these two options, right? So these two options have to be tested now. So if I take 9, Then you have something like 3 square whole to the power p is equal to 3 to the power 64, in which case p is equal to 32. You can just solve this yourself, equate the powers. And 81 is 3 to the power 4, it is 9 square. So this is the scenario that you get, right? And in this case, p comes out to be 16. So these are the two feasibilities, p equal to 32 or p equal to 16. But don't forget, what are you substituting? So this comes out when a is 9, and this comes out when a is 81. Also do something else. I mean, when a is 9, then log of a base 3 is basically 2, right? It's I mean, which power of 3? So that is the essence of log. Never forget the basics. I mean, you don't have to always apply properties and all. I mean, this is asking us a question, which power of 3 is a? And a is 9, so 9 is second power of 3, right? So this should be 2. And if a is equal to 81, then this log a base 3 will be equal to 4. So these are the two possibilities. So just substitute in the left hand side. So if I take 2, this comes out to be 2 square, which is 4, minus 12 into 2, which is 24. And then you have a 48, right? So 48 minus 24 is 24, and 24 plus 24 is 28. But this is not equal to p, right? That should be equal to p. And when a is 9, the p is 32. So this is not matching. So this goes off. So a is not 9. So that gives us the answer any which way. That is why I said this is fast. But anyhow, just test it out if you're not confident at this point. So just substitute 4. So if you have 4 here, so 4 square is 16, minus 4 into 12 is 48, plus 48. Now check this. I mean, this two cancels out. So this is 16, right? And that is exactly the value of p. So this matches. So for a equal to 81, the left hand side and right hand side both are coming out to be 16. So that should be the answer here. So this is an alternative way, but the main thing to catch out here is a to the power p is equal to 3 to the power 64. So a itself should be a power of 3. That is the first thing. Because most of the cases, these kind of questions, you will have integral related solutions. I mean, you don't have too much of complications. Otherwise, you know the solving method as well. And once you identify that a is a power of 3, uh, also look for those powers of 3 for which p comes out to be integer, because that is how the equation is formed, right? The left hand side is always an integer, whatever be the power of 3 that a is. So that's what I wanted to share. This is an alternative one. If you're not comfortable with it, I mean, if you are good with this powers and logarithms, so this should be comfortable to you. If not, work out a little bit. This is very, very fast. Trust me on it. You can try it out in some questions related to this actual CAT questions. Also, you can test it out. I have uploaded some solutions also, CAT actual papers. So in that, a lot of these type of questions appear, in which you, if you want to solve it, you can solve it, but using options, it becomes very, very fast, because that integral idea, we can test it out. Anyhow, that's all I wanted to add to this particular question. Hopefully everything was understood, and thank you.
Hopefully you liked the solutions we provided for these questions. And if you did like it, do not forget to like the video and share, subscribe, and comment. Do subscribe to the channel and click on the bell icon. In that case, you'll get notification as soon as we upload a new video. And if you want to check a bouquet of courses that we provide, so we have a huge variant of courses, from customizability to full preparation. You can check our website www.mathoratory.com. I'll leave the link in the description below. And have an enjoyable preparation ahead. Welcome to the Mathoratory family, and have a good exam ahead.